Hi everyone. In this class, we are going to discuss about force on a moving charge. Force on a moving charge. F, F suffix m bar is the magnetic force, and charge q is located at the origin. And v bar is the velocity, and v bar is the magnetic flux density. The force on a moving charge in a magnetic field shown in figure. A static electric field E bar exerts a force on a static charges or moving charges. Thus, according to Coulomb's law, the force exerted on an electric charge can be obtained as F suffix E bar is equal to Q into E bar. So this is the relationship between electric force and electric field intensity. This force is related to the force is related to the electric field intensity. That is, F suffix E bar is equal to Q into E bar. For a positive charge, the force exerted on it is in the direction of the electric field. For a positive charge, the force exerted on it is in the direction of the electric field intensity. This force is also referred to as electric force. This force is also called as electric force. So now consider that a charge is placed in a steady magnetic field. A charge is placed in a steady magnetic field. It experiences a force only if it is moving, then the magnetic force Fm bar exerted on a charge Q, moving with a velocity v bar in a steady magnetic field v bar. And it is given by the magnetic force Fm bar is equal Q into v bar cross v bar. Fm bar is equal Q into v bar cross v bar, where Q is the charge and v bar is the velocity, v bar is the magnetic flux density. The magnitude of the magnetic force is directly proportional to the magnitude of the charge, velocity, and magnetic flux density. The direction of the magnetic force is perpendicular to the plane containing velocity and v bar, velocity and magnetic flux density. The direction of the magnetic force is perpendicular to plane containing v bar and v bar. The electric force is independent of the velocity. Electric force is independent of the velocity of the moving charge by the electric field. So the electric force is independent of the velocity. Because of that, the electric force performs work on the charge. Electric force is independent of the velocity. Because of that, the electric force performs some work on the charge. In case of magnetostatics, the magnetic force depends on the velocity of the moving charge. But Fm cannot perform work on a moving charge. That is, Fa bar dot dl bar is equal to 0. So the total force on a moving charge in the presence of both electric fields and magnetic fields. Both electric fields and magnetic fields. So that is, the total force F bar is equal Fe bar plus Fm bar, where F suffix E bar is the electric force, F suffix M bar is the magnetic force. So what is electric force? Q into E bar, and what is the magnetic force? Q into V bar cross V bar. So on RHS side, both the equations, charge Q is common, Q into E bar plus V bar cross V bar. So this equation is called as Lorentz force equation. This equation is called as Lorentz force equation. So this relates mechanical force to the electrical force. So this relation relates the mechanical force to electrical force. If the mass of the charge is m, then we can represent F bar is equal to m into A bar. That is equal A bar is the dV bar by dt. That is equal Q into E bar plus V bar cross V bar. If the mass of the charge is m, that can be represented by the relation F bar is equal to m A bar. That is equal m A bar is dV bar by dt.